All right, this video, I'm going to do a couple more problems from that same section I did in video 2. So the two problems I've chosen are number 109 and number 113. So recall that in order for you to have a maximum or minimum, you are going to have the derivative of this equaling 0, looking for max or min, potentially undefined. All right, so let's take a look. So number 109, we're going to take the derivative of this. So root x is really x to the 1/2 power. So we've got 4 times 1/2 times x to the negative 1/2 when we do the derivative of that. And derivative of x squared is just 2x, right? Okay. Our derivative of negative x squared is negative 2x. So we have to set this equal to 0. And I'm going to rewrite this. The 4 and the 2 cancel to just a 2. So we're looking at 2 over root x minus 2x is going to equal 0. Well, we can solve for this by setting these equal to each other. So I'm going to add 2x to each side to give me 2x equals 2 over root x. Okay. So now I can divide each side by 2. And when can this happen? So when can x equal 1 over root x? Well, that's only going to work when x is equal to 1. So here we know that x equals 1, and there's no domain problems. We've got square root of x is fine at 1, x squared is fine at 1, so that is our solution. All right, problem number 113, we take the derivative. Actually, let me do a little different step here. So let's rewrite this. That's how we would write this. So now we can take the derivative using our power and then chain rule. So y prime is equal to 1/2 times this whole quantity, 4 minus x squared. And then 1/2 minus 1 is negative 1/2. And we set this equal to 0, and I'll rewrite it as I do. So we set this equal to 0, and I get 1 over, oh, excuse me, I need the chain rule part. So the derivative of the interior is going to be negative 2x. So the derivative of 4 minus x squared is negative 2x. You need to have that. All right, so I don't have a 1 up here anymore. That's an x. All right, so the 2 and the negative 2 become negative 1, so it's just negative x in the numerator. And this is the square root of 4 minus x squared. So we're looking at this and determining when it can equal 0. And the only place this equals 0 is when our numerator is equal to 0, so that works at x equals 0. And that's no problem with the domain. Our domain for this domain of f of x. So this is going to work as long as x squared is not larger than 4. So if x is strictly greater than 2 or strictly less than negative 2, we're gonna have a problem. So this only works for values between negative 2 and 2. So 0 is within that domain of negative 2 and 2. So we're good, and that is our solution.